Welcome or welcome back to 3 Inquisitive Kids. In this video, I wanted to show you a geometry and algebra problem. And I wanted to show you how we can use what we learned in geometry and algebra, combine them together to solve a seemingly hard problem. So here's our question. What is the minimum value of this expression? At first, it sounds really hard and really confusing. Like, oh my gosh, what am I supposed to do? So let's first take a step back and see if we can notice some patterns that we might recognize. Here we see x squared plus 4. Whenever we see 4 or 9, we need to think of 2 squared, 3 squared. So that's using our number sense. Here we have 12 minus x squared plus 3 squared. And they all have a big. If you have done enough problems and your eyes or your brain is very sensitive to math, you might notice that this has something to do with the Pythagorean theorem, which is a squared plus b squared equals c squared. And a different way of rewriting the same theorem is we can take the square root of both sides. The square root of the sum of a squared and b squared equals c. And here you can see we have that exact format. In this case, x is our a and 2 is our b. So how can we use geometry now to help us visualize this problem? Well, let's first draw this out. So we can make a triangle that has a height of 2 because it's 2 squared and another leg that has a length of x. And the hypotenuse side would be represented by this expression. And then we're going to draw another triangle. So one side would be 3, and the other side would be 12 minus x. And again, this hypotenuse side will be represented by this square root. And now we've converted this algebra problem into a geometry problem. Here we have an x, here we have a 12 minus x. So what would happen if we just combined the triangles that we just drew together? We have a 2 and an x and a 12 minus x. Remember, these figures are not drawn to scale. And as you can see, I've flipped this triangle. After we combine these triangles, you can see that our base would become x plus 12 minus x. And we can simplify that to just get a constant value, which is 12. The x and the minus x cancels each other out. Now, this is easy. We only have constant values left because the variables got canceled out. And remember, here's our question. What is the minimum value of this radical plus this radical? Remember, each radical represents this leg and this hypotenuse. So what are these two values added together? Now, since we only have constant values, it's going to be easier. Remember when we learned about reflection and how we can use reflection to help us solve word problems? For example, let's say you have a river and you have factory B and factory A. And you want to build a port along this river, anywhere on this river, so that the distance from A to, let's say, O, this is the port, and O to B are the smallest as possible. So how we did these type of problems was we would reflect one of these ports across the river to get A prime, let's say, and we're going to connect A prime and B to get where we were going to build the port. And now we could do the same thing for this problem. What we're going to do is we're going to reflect, let's say, this point down here to get A prime. I'm going to call it A prime. And then we're going to connect the dots. Remember, this is not drawn to scale. And let's say that this point is B. So all we have to do is now find the value of A prime B. And after we draw this big diagonal line, we can also create another right triangle from it. We can extend this line to get a bigger right triangle. Again, our base would be 12. We can bring this 12 down. But now, since we've reflected this point, A, this part would be 2. The height is 2. And so this entire side would be 5. Now, in order to find the value of A prime B, we can use the Pythagorean theorem. So we can do 5 squared plus 12 squared, which gives us 169. And we know that the square root of 169 is 13, which means that A prime B would equal 13. So our answer, the minimum value of this expression, is 13. And that was our video for this problem. I hope you learned something from this video. And this is a very good example of how geometry and algebra can be used together in a problem.